Welcome to a slow, beginner-friendly lesson on why databases matter, made for absolute beginners. The data chapter begins. Today we open a new door. You learned files, JSON, CSV, plain text. Files are how you persist data to disk. They work. But at some point, files hit a wall. You have too many records, too many queries, too many concurrent writers. That is when you need a database. Today is a concept lesson. No code yet. We answer one question: why do databases exist, and what problems do they solve that files cannot? The most important concept in A.8. Here is where we are. In A.6 you learned how to read and write files, JSON for structured data, CSV for tabular data, plain text for simple values. In A.7 you fetched data from APIs and processed the JSON responses. But there is a question we never answered: where does all that data actually live? If you save API responses to a JSON file, you are using a file as a database. That works for small data. It breaks for large data. Today we explore why. From files to databases. You learned files in A.6. JSON, CSV, plain text. Files are great. But at some point, files are not enough. Files got you far. Look at this. 3 users in a JSON file. Reading them is trivial: JSON load, loop over the list, print each name. Writing is trivial too: modify the list, JSON dump. For 3 users, a file is the right tool. It is simple. It is portable. It is human readable. No database needed. Do not over-engineer. If your data is small and your access pattern is simple, files are genuinely the better choice. Do not over-engineer, but look what happens as data grows. Problem 1. Finding one user among 10,000 means scanning the entire file line by line, slow. Problem 2. 2 scripts writing to the same file at the same time corrupt the data, no locking. Problem 3. Nothing stops you from storing a user with a missing email, a duplicate ID, or an invalid type, no integrity checks. These 3 problems, querying, concurrency, and integrity, are exactly what databases were invented to solve. 3 walls. 10 users? Files are fine. 10,000 users? You need something designed for scale. Scale changes everything. Let us look at each problem. First, querying. If you want to find one user in a CSV file with 10,000 rows, you read every single line, split it, check the ID, and stop when you find the match. That is 10,000 reads for one result. A database uses an index, a structure that works like a book's table of contents. You ask for user 42, and the database jumps directly to the right record. No scanning. Milliseconds, not seconds. Scanning is slow. This is what file-based search looks like. Load the entire JSON file into memory. Loop over every user. Check each email. Break when you find the match. For 3 users, this is instant. For 10,000 users, you are loading 10,000 records into memory just to find one. For 1,000,000 users, the file might not even fit in memory. The approach does not scale. It works, but it gets slower and slower as data grows. Load all, check each. Second problem, concurrency. Imagine 2 scripts running at the same time. Script A reads users.json, adds a new user, and writes it back. Script B does the same thing at the same moment. Both read the original file. Both add their user. Both write. The last writer wins, and the first writer's data is silently lost. Files have no locking, no coordination. Databases solve this with transactions and locking, one writer at a time, guaranteed. Last writer wins. Third problem, integrity. When you write JSON by hand, nothing stops you from creating a user with a missing email, a duplicate ID, or a phone number where the name should be. The file accepts anything. The problems show up later, when your code tries to read a field that is missing or has the wrong type. Databases enforce rules: this column is required, this ID must be unique, this column must be an integer. Bad data is rejected at the door, not discovered later. Bad data slips in. A database is not magic. It is a tool designed for one job: storing, finding, and managing data efficiently. A system, not a format. So what does a database actually give you? 3 things. Fast queries, indexed lookup instead of scanning, so finding one record among millions takes milliseconds. Safe concurrency, transactions and locking, so 2 scripts can write at the same time without corrupting data. And data integrity, constraints and types enforced at the database level, so bad data is rejected before it enters. These 3 gifts are why every serious application uses a database instead of flat files. 3 gifts. Here is the mental model. A database is not just a file format like JSON or CSV. It is a system for managing data. You talk to it with a language called SQL, Structured Query Language. SQL lets you create tables, insert rows, query with conditions, update records, and delete data. Every database, whether it is SQLite, PostgreSQL, MySQL, or Oracle, speaks SQL. Learn SQL once, and you can talk to almost any database in the world. That is a powerful skill. SQL is universal. Here is a taste of SQL. Create table, define columns with types and rules. ID as an integer and the primary key. Name is text and cannot be null. Email is text and must be unique. Insert, add a row with values. Select with where, query for a specific record. 3 lines of SQL, and the database handles indexing, locking, and integrity automatically. We will go slow on each of these in the lessons ahead. For now, just see the shape. Just the shape for now. Every application you use, every website, every app, every cloud service, is backed by a database. Every app needs one. Why am I emphasizing this? Because every cloud application you will ever work with is backed by a database. Every website stores user accounts, content, and transactions in a database. Every API you call is reading from and writing to a database. Every cloud service, Amazon, Google, Microsoft, manages data at enormous scale. As a cloud engineer, you will work with databases daily. Understanding what they are and why they exist is not optional. It is the foundation of your career. Not optional knowledge. Look at the progression we have built. In A.5, you learned collections, holding many values in memory while your program runs. In A.6, you learned files, persisting data to disk so it survives after your program exits. In A.7, you learned APIs, fetching data from the internet. Now in A.8, you learn databases, the structured, scalable way to store, query, and manage data that grows beyond what files can handle. Each layer builds on the previous one. In memory, on disk, remote, structured. So when do you use a file and when do you use a database? Files are right for small data with simple access patterns, a config file, a log file, a list of settings. Databases are right for large data that needs fast queries, concurrent access, and integrity, user accounts, product catalogs, orders, messages. The rule of thumb: if you are scanning every record to find one, you should be using a database. If you read the whole file every time, you should be using a database. Practical judgment. A light mention: there are 2 families of databases. Relational databases store data in tables and rows, and you query them with SQL, SQLite, PostgreSQL, MySQL. NoSQL databases store data as documents or key value pairs, MongoDB, DynamoDB. This course focuses on relational with SQLite, because SQL is a universal skill and SQLite is the friendliest starting point. The concepts you learn, tables, queries, joins, transfer to every relational database and give you the foundation for NoSQL too. SQL transfers everywhere. Next we meet SQLite, the friendliest database in the world. Zero setup, ships with Python, real SQL. Meet SQLite next. Quick self-check. Can you name the 3 problems files have at scale? Can you name the 3 things databases give you? Can you say what SQL stands for? Can you explain why a cloud engineer needs to understand databases? If any feels shaky, rewatch the matching part. You do not need to know SQL yet, just why databases exist. Say each out loud. Files work for small data. Databases work for large, queryable, concurrent data. A database gives you 3 things files cannot: fast queries through indexing, safe concurrency through transactions, and data integrity through constraints. Every cloud engineer works with databases daily. That is why this module exists. In the next lesson, we meet SQLite, the friendliest database in the world, and it ships with Python. 3 gifts, 1 purpose. Next we meet SQLite. It is the friendliest database in the world. Zero setup, no server, no daemon, no configuration. It ships with Python. Import SQLite 3, and you are ready. 1 file on disk is the entire database. And it speaks real SQL, the same language PostgreSQL and MySQL speak. Everything you learn with SQLite transfers. Let us open the door. Zero setup. Real SQL. If you want to reflect, think about data you work with in your own scripts or projects. Is it small and simple? A file is fine. Is it growing and you query it often? Time for a database. Do multiple scripts write to it concurrently? Definitely a database. When you can look at your own data and know which tool fits, you understand why databases matter. Look at your own data. Thanks for learning why databases matter. Next we meet SQLite, the friendliest database in the world. The door is open.